Hello and welcome back. Today's video is actually a repeat of information that has been previously released. I know several folks have wanted to get a lot of the information on Sarms, BPC 157, and a few other compounds in a bit of an easier to digest single video here. This has been previously only released on my Patreon, and instead I am putting it up here as a bit of an added bonus. Hopefully you enjoy the information. Now, Sarms, selective androgen receptor modulators, BBC 157 known as Bepicin, a few of these other compounds have been around for quite some time. And there is a lot of information and misinformation on them, a lot of properties assigned to them that may or may not be true. So in this video, I kind of attempt to give a little bit more explanation as to what they are, how they work, and what may or may not be true about them. So, yes, again, this was a series initially conducted last year. Now, as of late 2019, this information was as current as it could possibly be, so some of it may have changed. Given the rapid pace of development in this area, it may be worth revisiting some of these conclusions, potentially next year. Now, SARMs are technically, yes, they are technically illegal in the United States for human use. Some of the other compounds are called gray market compounds, in which they are legal to purchase and investigate, but are not specifically labeled for human usage. Bepicin is one of them, BPC 157. So effectively, when looking at this information, please note that all of this is really for informational purposes only, and I do not recommend or endorse the use of any of these compounds unless they are legal in your area. Please throw in a whole bunch more caveats. And without further ado, here we go. Okay, one question I've been getting a lot, and I actually mean getting a lot, not just people say like they get a question a lot so they can talk about it. No, actually get a lot is about SARMs. What are they? How do they work? And which ones are any good? Well, a SARM, as anybody with Google can figure out pretty quickly, is a selective androgen receptor modulator. It is a compound that ostensibly has effects similar to androgens like testosterone, but none of the side effects. Now, sound too good to be true? Well, first let's talk about how they work. First, let's talk about the androgen receptor. When people tend to think about cellular receptors, they think about those little things on the outside of the cell, and something comes along, activates the receptor, it either gets pulled into the cell or does some magic inside the cell and stuff happens. The androgen receptor is located inside the cell. Now, androgens like testosterone are readily pulled into the cells, and when they find this androgen receptor, they induce a conformational change in the receptor molecule itself. That receptor now binds to other cofactors, transfers to the nucleus, and binds to DNA. Now, this complex of androgen receptor, which is activated, testosterone, and any other cofactors, goes along to DNA and activates whatever genes, whatever proteins they happen to be coding for, like skeletal, contractile, muscle proteins, for example. Now, SARMs are not androgens. Remember when I said androgens bind to the receptor, they induce a conformational change? The change that SARMs bring about is slightly different than testosterone would, which changes how the cofactors bind, or which cofactors bind. So if you really want a terrible analogy, think about the androgen receptor as a car, the androgen as a driver, and the cofactors as passengers. The driver gets in the car, picks up different passengers depending on who the driver is. Those passengers or cofactors are going to tell the car where to go. So basically, since SARMs have different shapes and different configurations than conventional androgens, they're going to bind with different cofactors and potentially activate different genes. Now, remember I said potentially, this is still theory. So why does this matter? Well, first of all, it helps explain why these are selective compounds. In other words, activation of different cofactors in different tissues can affect different gene expression, which might explain the low incidence of virilization and other negative side effects. However, the other downside to that is we don't actually know 100% which cofactors are being activated, which are not, what genes are being activated, and what tissues. We don't have fully comprehensive data on the exact impact of SARMs in all tissues. So this is also why certain SARMs have different side effects. For example, S23, which is being investigated as a male sterility drug, reversible of course, for male birth control, has different effects to, say, ostarine, which has different effects than andarine. And this is also why clinical trials on these compounds have kind of hit a brick wall in a lot of cases. Ostarine, for example, had some great phase 3 trials done, but only certain endpoints were met. When it comes to muscle wasting, they prevented muscle loss, but didn't increase strength.
first one we're going to talk about in the next installment, is ostarine. But just to give you a slight preview, ostarine is a fantastically interesting compound. Low incidence of virilization side effects, very low suppression, and at therapeutic doses does seem to show increase in muscle mass. Potential negatives is that at higher doses there does seem to be some suppression, some effect on lipid profiles, or LDL, HDL, etc. Some impacts on blood pressure, and interestingly enough, less increase in performance than the change in muscle would indicate. Alright guys, so we're going to get into ostarine itself. Now ostarine is the one that I've received the most questions on, and rightly so. It's had a lot of press. It seems to be well tolerated by people. A lot of people have reported they've used it before with minimal side effects. So is it really that good? So first let's start with the bad. Now, contrary to some popular belief, ostarine is not completely without side effects. It may not have virilization on its own, but it does affect endogenous hormones. In fact, in high doses, it can be suppressive to your natural production. Even at clinical doses of 3 milligrams per day, it decreased sex hormone binding globulin, decreased estradiol levels, and in other words, it can be suppressive and it can slightly skew your natural hormones. In fact, it can have some negative effects on blood lipids. So while ostarine itself may not have significant effects on non-skeletal muscle type tissue, remember, when you're taking it, your body downregulates production of endogenous hormones, and that can be potentially with its own set of risks. So because of that, if anybody has any plans on using it, it's highly recommended that it be used in short 3 to 4 week periods, and of course you have your lipids checked and blood pressure checked before, during, and after. Also, at low doses, it doesn't seem to have much impact on luteinizing hormone or FSH, but at high doses, it can start to be suppressive there. So if anybody has any plans on trying to have kids, this may not be the best way to go about it. You may want to take a significant washout period before you try. On the plus side, there is no doubt that it is effective, clinically proven to help build muscle, reduce muscle loss in dieting or in case of illness, improve bone density, and in other words, in every other regard, seems to do exactly as advertised. So the question you should always ask yourself when you see a compound that seems too good to be true is, well, why isn't it available for cancer patients? Why isn't it available for muscle wasting? Well, the answer to that really lies in the whole clinical trial process itself. For those of you that don't know the 3 phases of drug development, phase 1 is safety testing in healthy normals, phase 2 is dose finding and efficacy testing in sick patients, and phase 3 is effectiveness testing. In other words, is there a clinically significant positive effect on a disease state? Why is this important? Well, it passed phase 1, so they know it's safe. They passed phase 2, so they established the dose of 3 milligrams a day to prevent muscle wasting. It's just in phase 3, it didn't meet those endpoints, and getting it through phase 3 is critical to getting to market, and phase 3 trials are very expensive. So conclusion on ostarine. At 3 milligrams per day, it's been tested to prevent muscle wasting. I've seen people take anywhere from 5 to 20 milligrams a day. Anything above 10 milligrams a day, people start to see real problems with lipids, and endogenous suppression doesn't necessarily mean dangerous, just something you need to look out for. Do not take if you are a drug-tested athlete, of course. Do not take it if it is illegal in your area. Do not take my advice as substitute for medical advice. There's like 30 more caveats. Look, you know what you're doing. If you're here, you're asking the question, you know exactly what the compound is. Is it good? Yes. Final caveat, GTX, the company that makes it, did not even release the chemical compound at any point. So the likelihood that what you're getting is actually ostarine and not andrine, a similar but different compound, is fairly low. Chances are people have figured it out since people have been busted for it, but hey guys, next up in the series is a compound called cardarine, or GW50156. Important to note, this is not a SARM. It is not an androgen receptor modulator. It is a PPAR agonist, or peroxisome proliferator activated receptor agonist. Now, there are multiple PPAR subtypes, and they are expressed in almost all tissue and play roles in everything from cell metabolism to cell differentiation, fat burning, lipolysis, carbohydrate, energy metabolism, the whole range. We actually discussed a couple of the properties on here before. If you remember both the segments on the ketogenic diet and CBD, one of the PPARs is actually responsible downstream for COX-2 expression, which makes it a potent pro-inflammatory process. So if you recall, both some of the anti-spasmodic, anti-epileptic properties of the ketogenic diet are actually because of its impact on PPAR activation in the human body while on the diet. CBD actually is an agonist for other kinds and reduces inflammation. Now, PPAR delta, which is what's impacted by cardarine, is actually also affected by exercise. In fact, being able to switch the body's energy source from glucose to lipids is one of the functions of PPAR delta, oversimplified of course. Now, this compound has been called exercise in a bottle because it effectively increases the body's ability to burn fat as fuel. It was originally investigated for properties in both treating diabetes and for improving blood lipids, reducing your cholesterol levels overall. Now, taken on its own, it has beneficial effect on blood lipids, but none really on exercise performance or endurance performance. However, in conjunction with endurance performance, in early trials, especially in rats, it almost doubled their time to exhaustion in 8 to 12 week trials. Well, we'll start with two things. First, the less bad. First of all, if taken in large amounts, the BCAA requirement, the amount of BCAAs burned by fatty tissue at rest and during activity, increases dramatically. What does that mean? It means your body will burn protein. In fact, if taken in large amounts, a compound like GW501516 could potentially lead to significant muscle atrophy. That's obviously a bad thing. Now, will taking BCAAs mitigate this? Potentially. Don't know. Secondly, PPAR delta agonists play an unknown role in cancer. In some cases, they seem to block tumor formation, and others they seem to increase it. While phase 2 trials were ongoing, further preclinical data showed an unacceptable safety profile. Until any sort of definitive clinical data can show that these compounds won't play a role in tumor formation, like they actually have in rat models, it's extremely unlikely that any pharmaceutical is going to further advance these compounds through phase 3 trials. Overall, while this is a promising compound for both health and performance, if you do a cost-benefit analysis, the potential cost, even if the likelihood is that low, given that the magnitude is that big, I just can't recommend it. Peroxisome proliferator, activated receptor, selective androgen receptor modulator. Hey guys, welcome back. So today I'm going to be continuing the segment on Sarms, discussing the two compounds mentioned in the previous slide. I think we're going to be discussing them together because I think it's important to know how these two compounds compare and contrast, i.e. what do we know about each. First of all, the reason we discussed ostarine first, ostarine has been studied much more extensively. It has gone through more preclinical testing, more clinical trials, has progressed further in clinical trials, and in other words, far more developed with a far greater understanding of the potential therapeutic profile than these two. Now, out of these two compounds, one of the common things you hear is that RAD140 has better mass gaining potential more side effects in terms of water retention, etc. And people say that LGD4033 is actually better for things like endurance. Now, indeed, there's been some interesting properties noticed of each, especially in preclinical testing. In rat models, LGD4033 seems to show great all-around muscle growth over a rat's entire body. That's unusual. That's typically not studied. Additionally, researchers studying LGD4033 seem to show that it maintained rat copulatory behavior. Why is that important? Well, because any exogenous compound that is not testosterone that affects the androgen receptor could theoretically suppress natural sex drive. This is because you can argue that these exogenous compounds are out-competing testosterone in certain types of tissue. That's always a concern when you take in a compound when you start to mess with kind of the natural HPG axis. So this is potentially interesting. For RAD140, one of the very interesting properties is that in rat models, as dosages increased, activity at the prostate decreased in a dose-dependent manner, which means it has the exact opposite effect in the prostate of testosterone. So the next slide is going to summarize what we know definitively about the differences in properties between LGD4033 and RAD140. And that is literally it. One of the most critical things to understand in pharmaceutical product development is that simply noting an effect in preclinical data does not mean other compounds in the same classification do not also have that property. So while people may note that ostarine has proven benefits to bone growth and LGD4033 has proven benefits to all-around full-body skeletal muscle hypertrophy, and while RAD140 shows potential reversal of prostate enlargement, it doesn't mean it's unique. Because really the biggest difference between these compounds is that they're owned by different companies. That is basically it. They all effectively may have different effects on the androgen receptor, but they all function in essentially the same way. And until comparative trials are done, we just don't know. And that's because that's all bullshit. If a particular potential benefit of a compound is noted in preclinical or clinical trials, it's because the scientists were looking for it. If a compound does not exhibit this property, but it's in a similar class, ask yourself, were the scientists looking for it? And when it comes down to it, all of these drugs have similar properties. They operate on the androgen receptor in similar ways. They exhibit similar side effect profiles, which is to say relatively low, but potentially suppressive with potential negative effects on blood lipids. They're all effectively the same. So I know that might not be the most satisfying answer, but that's the current state of the data we have available. In all these cases, if you're interested in trying one of these compounds, which is a purely personal decision, go with the one with the most clinical data behind it. Benefits of drawbacks, nothing I can speak to from a medical perspective. If you're already on testosterone replacement therapy, technically you should be having all your needs met from both a physiological and a psychological perspective, so why would you take Sarms? However, yes, if you're already on TRT, you will gain additional benefits to growth in skeletal muscle, athletic performance, etc. by taking Sarms on top of it. So yes, if that's what you're looking for, technically you can attain super physiological performance. Risks would be relatively marginal since you're already on TRT. There are no long-term concerns about suppression. However, you would have to be especially careful about things like blood lipids, blood pressure, etc. Since that's already a known side effect of TRT, it would be worsened. Yes, even if these compounds are minimally suppressive, they are still suppressive. Now, the exact nature of PCT I can't really speak to or won't really speak to here for legal reasons, but yes, the answer is yes. Okay guys, today's topic is BPC 157, aka Pentadeca peptide. Now, as you may gather from the name, this is a peptide, not a SARM, but I guess I had to cover it since so many people asked about it when I asked about SARMs. The narrative around this thing, it is a miraculous healing compound. It can heal torn tendons and messed up joints, and it can heal your gut, and it can do all kinds of miraculous things like help cure degenerative brain disease. So what's the truth? Well, if you're a rat, it appears to be able to do all these things. It is an extremely promising compound. It is comprised of 15 amino acids and was originally discovered in human gastric juice, and it is actually stable in human gastric juice, which is unusual. We don't really know. Given how many systems it seems to affect, it's hard to draw any kind of conclusions. It can affect serotonin regulation in the gut. It seems to be able to affect cell migration and proliferation around damaged tendons. It even seems to affect oxidative stress. What we do know is this: it does seem to have efficacy in tendon regrowth and repair. It does seem to have efficacy in healing of certain inflammatory gut disorders. It does seem to have some efficacy as well in helping with muscle tissue repair. Much less certain are the purported neuroprotective effects. Now, there seems to be some preliminary data that it could be used to treat depression, some preliminary data as well on neuroprotective effects that stem from resistance to neurotoxins and degenerative brain disease. Well, thus far there don't seem to be any side effects. Does that mean they won't find any in humans later? No, certainly not. Do you need to inject it? Well, given the nature of the compound, it would appear to be a no. Even though in rat trials it's always been injected, it does not appear to be location specific. In fact, in vitro studies have kind of confirmed that putting the stuff directly on damaged tissue, damaged tendons, does nothing whatsoever. So it would appear to be some sort of systemic effect that's responsible for its repair potential. The conspiracy theory you always hear, and you hear the same thing with CBD, is, well, since it's a naturally occurring compound, you can't patent it, so no one's going to make any money. From an insider in pharma, that's bullshit. You can patent pretty much whatever you want. You can patent delivery methods, extraction methods, different salts, pretty much whatever. In fact, a company named Diogen has done just that. They have patented a stable salt version of this compound, have named it Bepicin, and are currently doing pharmacokinetic and pharmacodynamic studies as well as enrolling phase 1 trials for it. So you may see it in humans. Yes, honestly, 200 micrograms a day appears to be pretty well tolerated by people with a low or no incidence of side effects. Of course, I'm not a doctor, can't say that for sure, etc., etc. There's not enough data. But taken orally seems to be just fine. There's no indication you need to inject. Now, a couple caveats, of course. If you have any sort of nagging joint injury, I would suggest you have a physician look at it first. Self-medication is really no substitute for good imaging. It's also no substitute for physical therapy as well. So, of course, simply healing a joint is never enough. The reason I caution against this, while you can heal a tendon, if you're dealing with issues like impingement, like bone spurs, like anything else that's causing any sort of physical disruption of the joint, simply healing a tendon is, of course, not going to be the solution you're looking for. That being said, go for it.